Let's look at how to write an equation for a polynomial given it has a degree of 4, a root of multiplicity 2 at x equals 4, and roots of multiplicity 1 at x equals 1 and x equals negative 2, and it also has a vertical intercept at the point 0, negative 3. So first let's look at each of these roots or zeros of the function. Each time that we know a root of a function, we also know a factor of the polynomial. So if your root is at x equals 4, your factor must be x minus 4. If your root is at x equals 1, your factor must be x minus 1. And at negative 2, it'll be an x plus 2. Now come back and look at each of these multiplicities. So the multiplicity is telling us about what happens at that particular root or zero. So an even multiplicity means the graph will touch, an odd multiplicity means that the graph will cross. For our equation, the multiplicity is telling us about the exponents on each of these factors. So a multiplicity of 2 means that it's going to be an x minus 4 squared. For a multiplicity of 1, it's going to be an x minus 1 to the first and an x plus 2 to the first. It's okay to leave off those exponents of 1. So let's write what we know so far. So our function will have some leading coefficient, which we'll come back to that step. And then we'll have x minus 4 squared, x minus 1, and x plus 2. So the one piece of information that we haven't used yet is that we have a vertical intercept at the point 0, negative 3. In function notation, this is telling us that f of 0 is equal to negative 3. So I'm going to take that input value of 0 and plug it in for all of the x's and then set my function equal to negative 3. So we have f of 0 is equal to a times 0 minus 4 squared times 0 minus 1 times 0 plus 2, and this should all be equal to negative 3. So 0 minus 4, we have negative 4 squared, so negative times negative is positive 16, times negative 1 times 2 needs to be equal to negative 3. So we have multiplying 16 times negative 1 times 2, we have negative 32a. It's equal to negative 3. So dividing, a is equal to positive 3 over 32. So taking everything that we found and putting it together, our equation for our polynomial function, f of x is going to be equal to 3 over 32 times x minus 4 squared times x minus 1 times x plus 2. That we have 4 total roots or zeros for this degree 4 polynomial, 1 of multiplicity 2 and 2 of multiplicity 1, and from our vertical intercept we find our leading coefficient a of 3 over 32.